Okay, we are going to finish up this chapter discussing amides. Think of amides as really similar to carboxylic acids. Instead of this OH here, we have the amine there instead, the nitrogen compound. Notice as a result, it can only have two things bonded to it because the rest of it is bonded to the carbon. So that means only primary and secondary amines are the only ones that can actually make an amide. So, for instance, the hydrogen and OH make the water. So that means that if it was a tertiary, where there's three carbons coming off of it, it wouldn't work because then the water wouldn't be able to be made and you wouldn't be able to get this attachment to one another. So when it's all said and done, you're going to have a double bonded oxygen and a nitrogen. To name them, it's going to end in amide. It's referring to like starting with the acid. I tend to start it with whatever the chain is and take off the E and add amide to the end. If there's something bonded to the nitrogen, think of that as a substituent. Just like we talked about with the amines, when it's on benzene, if it was attached to the nitrogen rather than the benzene ring, you put the N. Well, the N states that it was on the nitrogen. So N-methyl means that a methyl group is on the nitrogen. Ethane amide means that there's two carbons and it's an amide. Whereas in ethyl, propanamide. If it's a benzene ring attached to it, once again, it's going to be benzamide. If there's a substituent coming off of this, you act as if this right here in methyl, in ethyl, whatever it is, before it. If it's actually on the benzene ring itself, it starts as if it's what carbon number on the ring. Like if there's a chlorine here, it'd be 2-chlorobenzamide. Alright, so naming. There's nothing else coming off of this nitrogen, so I don't have to worry about that. We have 1, 2, 3, 4 carbons there. That's butane. But we're going to end it in amide, signifying that there is a nitrogen and a double bonded oxygen. For part B, we have an ethyl group coming off of the nitrogen. And then this is ethane. So it is ethanamide. But there's also on the nitrogen, on N, there's an ethyl group of ethanamide. Notice the N there saying that it's on the nitrogen. Alright, so let's draw some structures. Pentanamide. So we have an amide here, and it's pentane, so that means that there's 5 carbons. And on that 5th carbon, because it's an amide, there's going to be a double bonded oxygen and another nitrogen. Because there's no substituents written, just going to be NH2. Nitrogen always gets 4 bonds. Nitrogen gets 3 bonds. Carbon gets 4 bonds. So 1, 2, 3, 4. Fill those in with hydrogens. 1, 2, 3, 4. Fill those in with hydrogens. 1, 2, 3, 4. Hydrogens. 1, 2, 3, 4. All hydrogens. The next one, butylamide. So that means that there's going to be 4 carbons because of bute. It's an amide, so that means you have oxygen with a nitrogen. Notice in methyl, that means on the nitrogen we have a methyl group. So we have 1, 2, 3. Nitrogen gets 3, carbon gets 4. This one already has 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. And then this one is 4. And then there's those again. So here's some basic amides that are used in health, that are involved with health and medicine. Saccharin is the artificial sweetener. Urea is what's given off in your urine. It's also used in fertilizers to add nitrogen to the ground. We have some sleeping aids, and acetaminophen, which reduces fever and pain, and that's in Tylenol. It doesn't have the anti-inflammatory act that aspirin does, though. Here are the chemical structures of them. Notice the nitrogens in here. So we actually have an NH2. We have 2 NH2 groups in urea. And acetaminophen, here's the dividing line. That was the carboxylic acid at first, and here's the amine. These are the the things that help you sleep, and the nitrogen is actually embedded in the ring itself with the double bonded oxygen. Okay, so let's talk about the physical properties of amides. We talked about before with the amines that if we look at the periodic table, here's fluorine, here's oxygen, here's nitrogen. So nitrogen is still somewhat electronegative, but not nearly as much as oxygen. So it is going to have an effect on dissolving, but not nearly as much as oxygen would. So amides with 1 to 5 carbons will dissolve in water because they form these hydrogen bonds. If you have more than 5 carbons, that effect goes down. Here we have, this is the oxygen here from the double bonded oxygen, and this is the nitrogen. The oxygen is actually probably having more of an effect on the hydrogen bonds than the nitrogen is, because of the fact that it's more electronegative. But because there's 2 of them there, it would be more polar than, let's say, an aldehyde, which only has 1 oxygen here. Because it has an oxygen and a nitrogen, it's a little bit more than just 1 oxygen. So there's a couple different reactions it goes through, and that's acid hydrolysis and base hydrolysis. And essentially with these, we're breaking it into what it was before it became an amide. So here we have the amide. We have the nitrogen containing compound, and we have the double bonded oxygen. Essentially what's going to happen is there's going to be a line drawn between those 2, and it gets broken apart. Notice we have water here, and we have HCl. They've written the water as HOH to make it very evident that the OH stays together and that one of the hydrogen pops off. Well, in this process, the OH ends up attaching itself to that carbon, and that's why we get that carboxylic acid back out again. So what's remaining is that this nitrogen then becomes slightly negative momentarily because of the fact that it gets its electron back. So then it grabs a hold of this hydrogen. But because of this HCl here, it combines even further to get the ammonium chloride. And the reason it does that is because it's more stable than if it was ammonia by itself. And it actually helps the reaction go. We have a base here. Notice on the right hand side, the O and the Na stay together. So it breaks off the hydrogen. So when it attaches, the oxygen attaches itself to the carbon. So here's the carbon. The oxygen attaches first, and then the sodium, which looks weird when you write it because you're not used to seeing it that way. But the oxygen is actually attached first. And then from there, the nitrogen comes along and picks up that hydrogen. So it's NH here, it's NH2 on the right. Notice this is producing a salt, which once again is an ionic compound. And remember, an ionic compound can be seen by having that negative and positive interaction. And those are the two reactions that you will be learning in this particular, with amides. So let's take a look at doing it on our own. The hydrolysis of N-ethyl propanamide with NaOH. So let's start with what this structure is. We have propanamide, which means there's 3 carbons because it's prop, with an oxygen, and it's an amide, so that means we have a double bonded oxygen and a nitrogen. It says N-ethyl, which means we have an ethyl group coming off of that nitrogen, which means we have another hydrogen here because nitrogen needs 3 bonds. Each carbon needs 4. So we need 2 more for this carbon. We need 3 more for this carbon. This carbon in the middle already has 4, so we go to the left, and that needs 2 more hydrogens. And this carbon needs 3 more hydrogens. So that is our starting reactant. We're going to react this with sodium hydroxide. Remember with this, the hydrogen gets placed with this nitrogen. And then the oxygen and sodium stay together to get placed on this carbon. So when we're done, we're going to have 2 different things. We're going to have, once again, we have 3 because of the prop with the double bonded oxygen. But instead of this nitrogen being here, we're going to have it bonded to an oxygen and then to a sodium. And there's our charges. That's our salt. And then we have this nitrogen compound here that picks up another hydrogen. So we have nitrogen with 2 carbons bonded to it, and the hydrogens that go with it. It started off with 1 hydrogen. Now we're adding another hydrogen to it. So this is the hydrogen that was added to it. That was once bonded to the carbon. And there is our answer again. Notice it goes from NH2 or NH to NH2 because of this hydrogen here, and it splits off here, which would have been right there, and that's where the oxygen and sodium come in. And that is the end of the amides.